There is a 2024 GMC Sierra Denali sitting on the side of a Texas highway right now with a hole punched clean through the engine block. Not because the driver abused it, not because they skipped an oil change. It had 1,412 miles on the odometer. The connecting rod didn't just fail, it turned into a projectile. It punched through 6 millimeters of cast aluminum, dropped hot pressurized oil onto a 900-degree exhaust manifold, and set the engine bay on fire. The truck was brand new. The driver had made 7 payments. This is not an isolated incident. I have pulled the federal documents, the actual NHTSA filings, the engineering analyses, the recall queries, and what they describe is an architectural collapse inside one of the most popular truck engines in America. And the fix that General Motors is telling you to trust? The federal government is currently investigating whether that fix is making engines fail faster. By the end of this video, you will know exactly what is happening inside the 6.2-liter L87 V8, why the dealer's oil change remedy is an engineering band-aid on a structural wound, and if you own one of these trucks, what your legal options are right now, because some of them are worth more than $170,000. Let's go. The L87 is the 6.2-liter Ecotec 3 V8, 5th generation small block. General Motors put this engine in everything that carries their most expensive price tags. The Silverado 1500, Sierra 1500, Tahoe, Suburban. We are talking about trucks and SUVs ranging from $65,000 to over $110,000 brand new. This engine uses direct fuel injection, variable valve timing, and a system called dynamic fuel management, which cycles the engine between 4 and 8 cylinders depending on load. That last detail matters because the oil delivery system is managing complex pressure changes constantly. There is very little margin for error in the lubrication circuit. Now here is the physics that makes this failure so catastrophic. Your connecting rod bearings, the parts that link the pistons to the crankshaft, are never supposed to touch the crankshaft directly, ever. They ride on what's called a hydrodynamic oil film. Your oil pump forces pressurized lubricant into a gap that is thinner than a human hair. That film of oil is what separates two metal surfaces spinning at 4,000, 5,000, sometimes 6,000 RPM. The entire system depends on that film never breaking. When it breaks, even for a fraction of a second, the bearing starts to die. General Motors' own Part 573 Safety Recall Report, the document the company is legally required to file with the federal government when they acknowledge a safety defect, states verbatim that the root cause traces to manufacturing quality and contamination issues at supplier facilities, specifically crankshafts with out-of-specification dimensions and surface finish. The crankshaft part number is 127325518. The connecting rod part number is 127145549, both flagged in the federal filing. What that means in plain English, the crankshafts coming off supplier lines in Mexico and China were machined wrong. The surface was too rough at the microscopic level, burrs, incorrect geometry, dimensional variance outside tolerance. When that crankshaft goes into an engine, the hydrodynamic oil film cannot maintain itself. The rough surface shreds it, metal contacts metal, the bearing starts generating heat, the clearance grows, oil pressure drops, and once oil pressure drops in this engine, you are on a countdown measured in minutes, not hours. The sediment issue compounds everything. Investigators found metallic contamination inside the crankshaft oil galleries, the internal passages that feed oil to the bearings. That contamination acts like an internal grinding compound. It attacks the bearing material from the inside continuously every time the engine runs. But here is what stopped a lot of engineers cold when the teardown reports started coming in. Some of these engines are not failing at 1,400 miles. Some are failing at 4 miles. 4 miles. There's a documented case, a 2023 Cadillac Escalade that seized completely and needed a full engine replacement after being driven 4 miles from the dealership. When the independent shop tore it down, they found that a wrist pin retaining clip, a small circlip whose entire job is to keep the wrist pin from walking sideways inside the piston, was simply missing. Not broken, not failed, missing. It was never installed. Without Without that clip, the wrist pin migrates laterally during combustion. It contacts the cylinder wall. It scores the aluminum. It fractures the piston skirt. And then the connecting rod, under the mechanical stress of a compromised piston, snaps. The bottom half drops into the oil pan. The top half goes through the cylinder wall. This is not a wear failure. This is an assembly line quality control collapse. It means that on some percentage of these engines, the defect was introduced in the last few seconds before the engine was sealed and shipped, and there is no amount of careful driving, no break-in procedure, no oil viscosity on earth that will save it.
And this brings us to the part that owners find genuinely infuriating once they understand it. Every GM owner's manual for these trucks includes a formal break-in procedure for the first 1,500 miles. No full throttle acceleration, no hard braking, do not tow anything for the first 500 miles, avoid sustained highway cruise until 1,000 miles. Owners of $90,000 and $110,000 trucks take this seriously. Some change the oil voluntarily at 1,000 miles to flush any metallic particles from the initial seeding process. They are doing everything right. And then, at mile 1,412, mile 1,380, mile 1,497, the engine seizes on the highway. The brutal irony is that the break-in period is precisely when the compromised crankshaft surface finish is doing its worst damage. Every revolution of that rough crankshaft is wearing the bearing material at an accelerated rate. By the time the owner reaches 1,500 miles and feels comfortable pushing the truck, the bearing clearances have already grown past what the oil pump can compensate for. The system is already failing. The break-in period didn't protect the engine. In these cases, it just set the timer. In April 2025, General Motors issued recall 25V274. Nearly 600,000 vehicles in the United States alone. Worldwide, the number reaches roughly 721,000. Silverado, Sierra, Tahoe, Suburban, Yukon, Escalade. Production dates March 2021 through May 2024. The scope of that recall was already alarming, but the remedy they proposed is what turned this from a mechanical scandal into an engineering ethics conversation. Here is the official fix. If your engine is not already making audible knocking sounds when you bring it in, the dealer changes your oil. That's it. They swap the factory-recommended 0W20 for a thicker 0W40. Initially, they told dealers to use Mobil 1 Supercar 0W40. Then, GM quietly revised those instructions to use Mobil 1 FS 0W40, a European spec formulation, citing availability and cost. They also reduced dealer reimbursement in the same memo. I want to be precise about what this means mechanically, because the distinction matters. Thicker oil fills wider gaps. When your bearing clearances have grown because the surfaces have been damaged, a thicker oil temporarily reduces metal-on-metal contact and quiets the noise. From the outside, the engine sounds healthier, but the bearing surface is still damaged. The crankshaft surface finish is still wrong. The metallic contamination in the oil galleries is still there. The thicker oil is not repairing anything. It is masking the symptom while the structural damage continues.